with the hardware section done. In this section, we'll be covering the client and server mapping of the DNP, and we'll be covering the calculator expressions, whether it's an evaluation expression, a quality expression, type conversion, assignment, how to do timers, and how to do averages in calculator. Thank you. Okay, in this section we'll show you how to basically create a client map between the D400 and the UR software. Basically we have a UR set up for DNP communication, and we've got contact inputs mapped into the DNP communication. Just to show you how the contact inputs will change. So here I'm going to change point number 5, point number 6 to on, point number 7 to on, point number 8 to on. Okay, and then we can switch it back to off. So contact number 5 off, contact number 6 off, contact number 7 off, number 8. Okay, and I'm going to show you the configuration that we did very quickly in under products, communication, DNP protocol. So you can see the DNP setup here. You can see the IP address of the DNP setup. You can also see the DNP point lists. And in the point list of the DNP, we only have mapped 4 digital inputs. There is no analog inputs with this, which is those 4 digital inputs that we did. Okay, so you can see contact input number 5, contact input number 6, contact input number 7, contact input number 8. Now this will translate to the D400 as point number 1, or sorry, point number 0, point number 1, point number 2, point number 3. Okay, so the D400 will pull the UR relay for point number 0, point number 1, point number 2, and point number 3. The UR relay will of course send contact input number 5, number 6, 7, and 8. Okay, so how do we do that? This is the D400 interface. I'm not going to take you through the login. That has been already recorded in the previous webinar. Once you log in, you go to the configuration tab. Under the configuration tab, you open the client maps. In the client maps, you can either open or create a new client map table. So I've created this F60 webinar client map. In the F60 webinar client map, so we don't have any analog inputs, analog outputs, digital outputs, or accumulators. We have placed the 4 points right under the address 0, 1, 2, and 3, and we just have a point reference on them. You can add a point. It's very easy to add a point. So in here, if I have a 5th point, I would have added as point number 4, and I can put a description for it, or I can delete a point. So this is how a client map works. The properties of the client map is defined in here. So what we're doing a class 1 poll every 1 second. We're doing an integrity poll every 3 minutes. If you are wondering about basically the timing for these parameters, you can get it from our user's manual from our technical website. Okay, so once you have set up your client map table and you have named it, you would save it, right? In this case, I'm going to save it as my webinar UF60 webinar XML, right? And then you go under the connections. In the connections, you would add IED block using the plus icon. In here, you will put the IP address of the UF60, and you would select the UF60 webinar client map that we just created. Okay. When all of that's done, you can save your configuration and commit it. So now if I go into my devices, I can see that the device is black. There is 245,000 communications between the D400 and the UR relay. If we go into the point summary, like from the previous webinar, then we can go into the details of the point summary. So under the details, I go to the digital input, and now when we do a change on the UR relay, you can see it. So point number 1 or contact input number 5 is on, point number 2 is on, point number 3 is on, point number 4 is on, right? In the same manner, we can turn it to off. So point number 1 is off, point number 2 is off, point number 3 is off, point number 4 is off. Okay, if we want to display it graphically, so we can go to our graphical display, and I built the graphical display, as I said in the previous webinar, under the graphical HMI creator. I just need to open my graphical display, open the HMI, and now I can see the points in this one. So I can go switch number 5 is on, switch 2 is on, 3 is on, 5, and then we go back. Switch 1 is off, 2 is off, 3 is off, 5 is off. Hopefully this gave you a very good understanding of the client map table and how this client map can be used for every other device. So when you add another device to your substation which have the same criteria, you don't have to create the client map again. You can reuse the client map and just go under your configuration, under your connections, just add an extra connection, use the same client map, and that client map became a template that you can always use it for the same device. Thank you. So now that we have the client map configured and we have configured some points into the relay from the UR relay into the D400, we're going to create an evaluation expression. So an evaluation expression in calculator, basically you can take a number of digital inputs and just add them or analog inputs, add them or them, right, and then create a value out of them. Common question that comes from the users is how do we do it under calculator? So under the configuration tab in your D400, you go first into the map point, you add your point. So in this case, we'll go to our multi-lane relay, and we add these points from the multi-lane relay into our mapped digital input points. So here we've got 0 DI, 1 DI, 2 DI, 3 DI. They're all added as a digital inputs from the list of digital inputs. If there is other digital inputs, for example, I can just check them or uncheck them, and immediately they will get an alias. That's that alias that you will use inside your expression in the calculator, right? And there is an easy way to access them once you start to build your expression. So the GUI has been simplified in order to help you as a user. And then we go under expressions. We highlight the evaluations expressions, and then we click plus to add an evaluation expression. Once the evaluation expression, it will show up like this. It will give us an output value. We can output either to a digital input or an analog input. So in this case, I'm outputting to an analog input, AI0. Okay, and when you build your expression, basically you can select the points by clicking on the map points, digital inputs. Like I said, the alias is already there, 0 DI, 1 DI, 2 DI, 3 DI. So I can pick those. And if you want to write your expression properly, you can use the shortcuts that are given at the bottom here for plus, minus, subtract, divide, greater than, less than, any of the assignments that you would like to do inside calculator. So 0 DI plus 1 DI plus 2 DI plus 3 DI. All I'm doing is I'm adding the digital inputs and I'm creating an analog input out of them, okay, to create an evaluation expression. Now to do that, I can, once that's done, I can go back, check on my device, right? The device is online, check on the points, right? And I can check either my IED points or my application points. So I can go to my calculator points and view the details. And under analog inputs, we've got this analog input number 0. And for analog input number 0, the value is 0, right? So as I toggle these, so I'm toggling number 5, see, became 1. Toggle number 6, contact input number 6, 2. Contact input number 7, 3. Contact input number 8, 4, right? If I take any of them out, so let's say I take number 8 out, so it becomes 3, take number 7 out, 2, take number 6 out, and then number 5 out, and it comes back to 0. Great, right? So you can see that it does work. And if we go to the graphical display of this, we can open an evaluation expression graphical display. So I just created an analog input display that shows the DI1 plus DI2 plus DI3 plus DI4. At the same time, it shows all the switches, right? So I'm going to switch number 1 on, or contact input number 5, and it closes. The analog input immediately show us that we have a contact input added. Contact input number 6, contact input number 7, contact input number 8, and we have a full scale analog input closed. In the same manner, we can go backward and switch off number 8, switch off number 6, sorry, number 7, switch off number 6, switch off number 5. And we have an analog input 0. Very simple. You just have to map your points, right? And then you can carry an evaluation expression on them. Thanks. In this section, we'll show you the timers expression. So we've shown you how to add a client map. We've shown you how to do an evaluation expression. Now I'm going to show you how to do a timers expression. To do a timers expression, first thing you need to do is, of course, you will have your points mapped in, and then you go to a timers expression. One common question that I get in the class always is, how can I learn how this timer expression works? There is a great online help. So if I click on the online help, it brings up the helpline, the help screen. If you go under calculator, let's go under expressions, go under timers, and if I read this, it says, the calculator provides time functionality to a resolution of 1 second. A timer operation is defined by 2 hold times: a rising edge, which goes false to true, and a falling edge, which goes true to false. Hold the time can be positive or 0. When the result of the binary expression changes, calculator starts the timer based on the defined hold time. So they're giving an example here, which is exactly the example that I'm going to implement and show it to you, right? So in this example, it's showing DI equal to DI, and they're assigning that to another digital input. Okay, so that's exactly what I did. I created a timer expression by clicking the plus. You get a timer expression. They give you immediately a digital input of it, so digital input number 4, and we get a 0 DI equal 1 DI. So I'm comparing contact input number 5 to contact input number 6, okay, which is coming back from the UR relay, as you've seen in the client map table. So I will go back to my basically point summary, and in this point summary, you will see that if I look at the details, if I look at the applications, calculator, details, and the digital input, okay, so now I've got DI number 4, which is set to on. Once I toggle contact input number 5, there will be a time of about 5 seconds, and it goes to off. All right, so I put this little widget just to show you now that this is, like I said, it's recorded in a different time. So again, and then we toggle the digital input number 6, and we give it 5 seconds. On the falling edge, it goes to on. If I want to show this graphically, just so that you can understand it, maybe a graphical will give a deeper understanding of it. So we'll go a timer expression on it. Okay, so if we switch contact input number 5, it goes to on. And then if we switch contact input number 6, so now they're equal, both of them are off. And it goes to on. Thanks. So we have shown evaluation expression, we have shown a timer expression. At this point, I'm going to show you an analog or a digital assignment expression. So for an analog or a digital assignment, the way it works is that you can take a digital output point, let's say a digital output that's owned by our multilin UR, and we can assign it a digital output point that's owned by the calculator in the D400. So for example, under the calculator points, we can go to digital output and we can add a point which we're going to use in our digital output expression. And then we go back to the expressions. We can write an expression like this one, which upon issuing of a close digital to digital output 3 it will cause a pulse to our relay digital output. Okay, so just to see this in action, we can go back to the points. We can look at the digital outputs that's coming back from the relay, from the UR relay. So we've got two digital outputs here. Digital output 0 is the one that we're going to control. Okay, and we can also take a look at the applications in calculator. If we go to details, under the digital output, we've got digital output 3, which is used in the output digital assignment expression. Okay, and what we're going to do is we're going to show both of these. We're also going to show the value from our relay. So if we close the digital output at this point, we issue a close command. That's on the calculator point. What will that in turn do is it will cause a digital output of the relay to close and will cause our status on the virtual input 1 to change. So it has been sent, and as you can see, the status is on. We can issue an unforce of that status if we want by setting a latch off from our UR interface point. And in the UR it will show as off. Okay, so for the calculator expressions, we have shown the evaluations, the timers, the analog or digital assignment, which is the same, and the quality. For a quality conversion, what does quality conversion mean? What that really means is that you can take a quality of a point that you have in the system, and you can choose that point type. So in this case, I chose the first digital input point so you can choose either an analog input, a digital input, or a digital output point. You can take even a calculator point and assign it. So I've chosen the first digital input that's coming back from my relay, and I'm trying to take an attribute of it. So you can take either the alarm inhibit attribute, the chatter, com lost, local control active, local force, offline, all date, output inhibit, overrange, overflow, questionable, reference check, remote control active, remote force, restart, scan inhibit, secondary source offline, tagged, and test and time sync. All of these attributes are available to be picked up. So I'll pick up the offline status, and I'm gonna assign it to a point that's owned by calculator, which is digital input number 5. Okay, so if we go back to our point list, just to show you how does it work. If I'm looking at the point, let's say the digital input 0, which is owned by my UR relay, coming back from the UR relay. Okay, and I look at my calculator point, digital input number 5. Okay, that we're using for a quality conversion. What we can do is we can, there is a forcing interface, a point forcing interface under the, so we can force the point to offline, okay, and then press close. See the digital input indicating the status of our digital input number 5 has changed to 1, which means that the point is offline. If I go back in, go to my point forcing interface, and I put it back to normal, the digital input number 5 would signify that it is it's online, it's not 0, so it's not an alarm anymore. Okay, hopefully that gives you a good idea of how the quality conversion can be utilized in order to know about the status of points, whether it's online or offline. Okay, covering the evaluation, timers, analog assignment, digital assignment, and the quality, we're going to cover the type conversion. So the type conversion would convert from one type of data, analog input, digital output, into another type of data. So if we put the digital input and we try to convert it to an analog input, right, that's owned by calculator, the value will be translated into that value, that just in case you need to transmit a different type of value to a master, like let's say the master will accept analog inputs, or you need to send that data to a master, so we can convert this digital input to an analog input. Just to show you how this type conversion takes place, we can go back to the point list and go to the details under the digital input, which is we're using digital input number 0 out of the UR relay. Okay, and under the analog inputs, so if we go back to the calculator points details, we will show the analog input, and under this analog input, which I'm using for type conversion, okay, take that out of the way. So when the digital input changes from 0 to 1, we expect the analog input to change value accordingly. So I'm forcing the digital input in the relay to 1, right, using my RTT tester, and the analog input would change to 1. The opposite is true. If I change it to 0, the analog input would change to 0. So this is what we mean by type conversion. Okay, so we have shown evaluation, timers, analog assignments, digital assignments, the quality conversion, the type conversion, and I'm going to show you the averages next. For the averages, basically we can have either a block or a time weight average, and the way it works is that you would take an analog input that's coming from a device. So in this case, I'm going to take the analog input that's coming from the UR relay, which I mapped into my client map, and so I'm going to take the current, and I will take an average of it every 6 seconds. So to do that, we have set the period for 60 seconds, and then we have our sub-block divisor every 10 blocks. So if you want a clearer description, it's in our help file under the averages, and as you can see, they split the period so into equal subdivisions. So it's explained in here. It says, for example, if you specify an average interval of 1 hour and a sub-block divisor of 4, calculator will calculate the average of the analog every 15 minutes. So quarter of an hour, 15 minutes, then the average will be calculated. It will report the average every 15 minutes if the sliding window is used, or every hour if it is set to a non-sliding window. Okay, so this is a sliding window option, and you can put exclusions if needed. So I've set up my analog input that is coming back from the UR relay to be averaged into AI2 or analog input number 2 that's owned by my calculator. So we're going to monitor the analog input that's coming back from the UR relay and the analog input that is in my calculator, just to see how to demonstrate this feature. So I'm gonna go back to points. I will, under the IED, I'll go click on details, click on the analog input. We can see the analog input, or what's referred to as AI3, that's mapped inside my calculator. Okay, and then I will go over to applications, click on the calculator, click on details, under the analog input, and we're going to monitor this average AI expression. Okay. Take that out of the way. Set it up. So the current is reading 3. As such, the average at this point is 3, right? And then basically at every 25 seconds, that average will be updated. So I'm going to vary it. So as you can see, we're reading from the device in the field 92, and the average started to go up as expected. Okay, I'm just going to keep it at 92, and the average should increase even more in the next minute. And now we can see that the average have reached the 90 average. Now if we put down the current on the relay back to 0, so at the top of the minute, again, we will see the average sliding down again as expected. So this analog input point that's owned by calculator will keep calculating the average of the analog input point that's coming from another device into the D400. And the value averages back to 11.85, as you can see here, right? And basically that's how the averaging works in under the calculator. Right, so we have covered the evaluation, the timers, the assignments, analog and digital assignments, the conversions, quality, type conversions, the averages. And the last feature of the calculator that I'm going to demonstrate to you is the output to input conversion. Why would we need an output to input conversion is a common question. Basically, the output to input conversion is a message that's coming from one master to another master, or a couple of masters. So let's say that there is 2 masters that are sharing the control over a set of bays or a set of points, and they need to communicate to each other as to which master is in control or which master is controlling those shared resources. The way it's done is we make a digital output available to both masters, and when one master basically forces that digital output, that's a message that gets converted into a digital input, and that digital input can be retrieved or polled, if you like, by the second master. So master 1 and master 2, we've got master 2 that's going to pick up that value and basically learn whether the first master is in control of the shared resources or is not in control of these shared resources. If you have more than one master, then instead of doing a digital output to digital input conversion, you can do an analog input to an analog output into an analog input conversion. So this way the analog output would be set by one master that would give the control to any of the available masters if there is more than one master to pick up the analog input value. So if the analog input the analog output is set up to 2 and the analog input is then picked as 2, which means that master 2 has the control on the shared resource. Or if the analog output is set up to 3, then the analog input would be set up in turn to 3, and the third master would have the control over the shared resource. This is an inherited functionality that was very successful in the D2X platform, and it's inherited and translated in our D400. Now, one thing to notice is that both points, the source and the destination, would be owned by calculator. So you just have to decide on what is the source point type and what is the target point type, and then calculator will pick the next available point slot that will be assigned these points as a digital output or an output to input conversion. So just to demonstrate this, we're picking digital output 1 of calculator and we're converting the value to digital input 6 of calculator. So if I go back into my point summary, okay, and we go into the applications this time, directly into the calculator. So under the calculator, we can go to the details, and in here we're looking at 2 points. We're looking at the digital input point, okay, so we're looking at the digital input point, which is an output to input conversion, and we're looking at the digital output number 1. When this digital output number 1 is basically latched on, if I go back to my digital inputs, I'll find my digital input number number 6 turned on, okay. And in the same manner, when that digital output changes, if I change it back to latch it to off, okay, I go back to my digital input and my digital input changed to off. So this digital output that's owned by calculator changes to a digital input that is also owned by calculator. With this, right next, we're going to show you how these points are going to be transferred to masters or to slaves. Okay, thanks. So once we have created our DPA or the DCA, the application that's collecting values from the field, that's our client maps, and we have added a connection to that client map, which is this device that's collecting information from the UR or all our field devices, and then we have created all our calculator points, our alarm points, and all of this information is ready to be transferred to the master or to be sent to the master. What we have to do is we have to create a server map. So a server map is a list of points that is a list of information that is ready to be transferred and be utilized by the master, whether this is digital input, analog input points that can be pulled by the master on a DNP protocol, or a digital output, analog output counter points that are ready for master freezing and reading and master control. Okay, so how do we build a server map? We go over to the server map in the same manner that we did the client map, and then we click New. We can either create a 101 map, a DNP, or a Modbus. Just to note here, if you need to do a 61850 setup, you will have to do 61850 in the sgconfig loader of 61850. It cannot be done on this online configuration. So we click on DNP, and then we click OK. It gives me basically an area where I can add my points that I need to report to the master, and then there is a tab for every data type, whether it's analog input, analog output, digital input, digital output, or accumulators. So what I'm gonna do is I'm gonna pick up some analog outputs from the device. So I'll pick up the voltage and current, okay? And for a digital, I got no analog outputs in the system. You don't have to pick up every type, okay? So from the calculator application, evaluation expression, analog input, type conversion, analog input, and averages, analog input. Okay. Then we can add some digital inputs if we want. So we'll go to the IED. Then we can add all of those 4 digital inputs that were coming from the UR. We can also add the calculator points. So the quality conversion digital input that we created, the output to input digital input point that is basically converts from a digital output that's owned by calculator. So as you can see, you're mixing between physical points or data that's coming from the substation and data that has been created inside the D400 as a soft point, or sometimes referred to as a pseudo point, like not a real point. Okay. We can also add the 2 digital outputs that are to be controlled by for the relay. Those are my virtual inputs in the UR relay, in case you're interested in how does it work in the UR relay. In the automation world, an output is an input in the protection world, and this is something just as a side note for those who are new to the field. Okay, and basically we can add a digital output expression. Okay, and the output to input conversion, this is the digital output. So now when we send this digital output point to the master has the ability to force this digital output point, and the value will be reflected in this digital input point, right? As we, this digital input point, as we have explained it in the output to input conversion. Okay. Of course, you can add accumulators. Now, in the case of accumulators, we don't have accumulators coming from the UR relay, but there is lots of accumulators on the UR software, or the application that's working with the UR software. For example, we can see how many messages were sent, how many messages were received, what is the timeouts for the message communication, how many messages with errors. Okay, and from a calculator point of view, We can see how many what commands were received by calculator, and how many of the received commands did not pass or didn't go through. As you can see, there is basically a lot of information available that we can take it and report it to the master. So another example is if you're interested in an IRIG-B frame count, right, to be reported back to the master, then you can pick up this IRIG-B point, and that will all be in the list. Okay, so at this point, we have populated the points that are going to the master, and this is the art of automation. You receive the points in a certain sequence, and then you would reframe it logically in a different sequence for the master. So the master right now can take these points and put them the way the master expects these points to be reported. All the attributes, similar to the attributes that we have basically configured in the client map, are available here. Now the number of attributes is much less. That's because when you're configuring a client map under the DNP protocol, you would have to specify how often we're going to basically poll the device and how often the device is going to reply to us. And all of those parameters may not be required in the case of data processing application or basically a server map. Okay, so in this case, the server map application that's serving to a DNP master does not require that we do any more than these specific simplified parameters. Okay, and as you can see, the parameters are specific to every type. So under analog inputs, I can decide what is my analog input class and what is the variation. So for those who are new to this, under the DNP protocol, there is object and variation, and you would decide what is the object and variation for each data type. So, and the class under which the data will be reported. So we're deciding that this is all, this data over here, these digital inputs are all class 1 data. You also have the option of inverting the data before you report it to the master. So let's say that there's a digital input that's coming into the D400, and what you want to report to the master is the inverse of that value. So if the value is 0, you would report 1. If the value is 1, you would report 0. And to do that, you would have to check the box that says inverted value. Okay. Now that my tables are populated, I would click Save, give it a name. Let's say my DNP webinar server. Now click Save. Okay, that XML right now is available in my D400. It can be used every time I want to add a master to the D400. Now we can go over to connections and then add the master. Say it's a network DNP master. Okay, and then we go and we decide whether we accept all hosts, or we can specify the IP address of the host that we want to talk to, what is the port that we should use, and what is the D400 address as a server. So 120. Under DNP, every device in the network has to have a unique DNP address. And that's different from our IP addressing or our communication port, physical port, if you're using serial number. It's an address that specifies the address of this device from a DNP logical network perspective. Okay. There is defaults that are set up for every device that's reporting to a master. If these defaults need to change, for example, you want to change the unsolicited class 1 mode, the class 2 mode, or class 3 mode. Unsolicited messages are messages that is basically sent to the master without the master pulling this information. So if that is required, then you would need to change them. You can use a custom setup instead of the use default setup. Okay, that's it. Your D400 is ready to report to the master. Once you're done, don't forget to save it and commit your configuration. Thank you. In this section, we have covered the DNP client and server mapping. We have covered all kinds of expressions for calculator and how to do timers and averaging. And if you need something that's beyond the calculator facility, you can refer to other webinars. For example, I've got a webinar on logic links, which is a great tool if you want to go and build a ladder logic in the D400.